The programs that were used to create this video are Camtasia Studio 5 and Microsoft Windows Movie Maker. Hello and welcome to XNA tutorial number 10. This is the last tutorial for the paddle series. And we have 2 more sections to go in this tutorial. Only about 10 pages left. So this section will be finalizing the game. And once we finish finalizing, we need to test it, then learn about distribution. Okay, so the game screen handles all objects, collision, and textures for the game. Remember, the only texture we need is a single pixel texture. So use the following bullets to help you create the game screen. We need 2 paddle objects, a player and a computer. 1 ball object, which is a ball. 2 public static int variables, score player and score computer. 1 public static texture 2D object, which we'll call pixel. Constructor. We want to initialize the player object with the position of 20, 275. Why 275? That Y value will center our paddle vertically. In 20, it'll give us a 20 pixel gap between the left side of the window and the paddle, left side of the paddle. We want to initialize the computer object with the position of 780, 270. 780 will give us a 20 pixel gap between the right edge of the window and the right side of the paddle. Both paddles should have a decent speed. I chose 8. Initialize the ball object with a slightly slower speed than the paddles. I chose 6. Load content method, public access with return type of void. We want to initialize a single pixel, which is the pixel object, by using game1.content to load the single pixel image. Update method, public access void return type, game time as parameter. Call a check collisions method. We have not yet created this method. Then we want to update each game object. Private access void return type. We will not implement that until later. Draw method, public access void return type and sprite batch as a parameter. We want to draw all game objects. So let's go into our code and start implementing the game screen. We want to have 3 new using statements using Microsoft.xna.framework. Copy that, paste that, framework.graphics for the second one, and using paddles tutorial dot game screens. Public class game screen. We want 2 paddles. Oh, we need another one. Game objects. We don't need game screens. We want 2 paddles, a player and a computer. We want a ball object called ball. We want 2 public static integer values as score player, score computer. We want a public static texture 2D and its pixel. Constructor. It'll have no parameters, and we want to initialize player is equal to new paddle, we need to pass a position, speed, and if it's player controlled or not. New vector 2, 20, 275, speed as 8, and true as it's player controlled. Computer is equal to new paddle, new vector 2, 280, 780, 275, 8, false. Ball is equal to new ball with the speed of 6. Okay, now we need to load content. Public void load content, and we'll set the pixel is equal to game1 dot content dot load texture 2D, and the asset name is single pixel. Now we need an update method, public void update, with a game time as a parameter called check collisions, and we'll have it auto generate that. And then update each game object. Player.update, ball, computer.update, ball.update. Okay. Now the check collisions we'll implement later. Now we need a public void draw with a sprite batch parameter, and we're going to draw all our objects. Player.draw, pass it sprite batch, and I'm going to copy this so I don't have to keep on typing it in. Computer.draw and ball.draw. Okay, that's it for that class, or so far. Now we need to create the check collision methods. So this will handle the collision. It will determine if an object comes in contact with each other. The only object that can come in contact with another object is the ball. The paddles can only move up and down, so they cannot come in contact with anything. There are some occasions where the ball will be in contact with the paddle longer than expected. We might have a large speed and the ball might be in the middle of the paddle. And we're going to reset the speed to a small speed and change the position. Or, I'm sorry, we're going to increase the speed and change the velocity vector. But if we update that ball and it still is in contact with the paddle on the next game loop, sometimes that can occur, it will change the direction of the vector again, and then it will cause all sorts of problems. So we need to add a